I started this journey in 2009. Though, as you know, I'm much older. So my first 15 years was in software. Then in 2005 to 2006 time frame, I decided, hey, genomics is the place to go to. Much more exciting than software. They'll tell you more about why that is and why software also helps that, understanding genomics. So after a lot of study and a lot of preparation, I decided to launch SciGenome. It's a short form of science of the genome. That is what my passion was. How will we understand the science of the genome? And the thought was that since genome is a very universal, the same language across all life forms, understanding the genome gives us the potential, or gives me or whoever the businessman the potential to create multiple companies in different verticals. So like I said, sequencing was very tough, and then the first human genome sequence took like about 10 to 12 years, work by many countries together to sequence the whole genome using the old technologies. If you just want to know 1 or 2 genes sequencing, Sanger sequencing is the best. But it's very difficult to use that for a lot of sequencing. So for human genome sequencing, the first human genome project, 12 countries, labs in 12 countries, it's a $3 billion budget, and it's a long story. But then by 2003, 2004, that was published, and then many new technologies started coming up. So you can see the cost coming down as the years went up. Why I put 2009, if you can see, that is when I started SciGenome, focusing on genome sequencing. So nobody had a clue on how it will flow, the rest of it, but most of us felt that the cost will keep going down. So genome sequencing, though expensive at that time, even it was costing like $10,000 to $15,000 at that time to do a whole genome sequencing, that is sequencing the full genome of a person. We all felt, or I felt, and many people felt that it will go down again. So if you start learning sequencing and if you start learning bioinformatics, that will give you a chance to do many solutions, to come up with many solutions using genomics. So that is when I started, and like us lucky, the cost of sequencing came up even much more dramatically over the last 10 years after 2009. So, and even still continues to fall. And very interestingly, if you look at it, all of you would know of Moore's law, right? Anybody in the computers, in the chip industry, the previous century, major developments in the chip industry happened because of, or was defined by Moore's law. That the power of sequencing, the power of chips and the cost of this thing would come down. So that was the ratio of how it would double in 18 months. And so this was so surprising to see that this curve, if you look at it, was much more, or is much more drastic than even Moore's law. Moore's law gave us the benefit of all the speed, the computer speed, right? The cell phones that you use now are much faster than the supercomputers of the 80s. So that is a change that happened. Here the impact is even much more. Why? Because the whole genome sequencing fell even much more. So now what it cost $3 billion to do 15 years back, we can do it for like $300 or $400. And what took 10 years at that time, now I can do it in a day. So think about the impact. So suddenly this opened up a huge field of genomics to anybody. You don't need billions of dollars of investment to do. You can do with a few $1 million, you can create a lab. And that's how I created SciGenome right here in Kochi, and use that as an incubator to build companies that can leverage this sequencing. So the first company I built out of there was MedGenome. So that is more relevant here. That's why I brought this company up, because we're talking about genomics and healthcare. So this was in 2010 when I incubated this as a division in SciGenome, and I started looking at, hey, which are the areas that genome sequencing can give benefit to patients. So I was based in the US, and most of the technologies also were coming from the US. So I was looking at, hey, what is picking up in the US? And there it was cancer, because like I said, EGFR for lung cancer, EGFR is the name of a gene. So if for example, if you have lung cancer, the first test the doctor will do is to see if the EGFR gene is causing that. It is mandatory. Because why? If it is an EGFR gene, then there is a medicine exactly for it. But only for about 25 to 30% of the people have the cancer due to EGFR. So it's not a cure for all lung cancers. But 25% is still a big number. Even more impactful was breast cancer. Because breast cancer, about 20-25% is through a mutation in a gene called HER2, HER2. So they were able to, by early 2000, they were able to come up with a drug which will clearly fix that. It will hit that HER2 gene. So in fact, that is one of the rare clinical trials that had to be stopped in between because it was so obvious who was getting the placebo and who was getting the drug. In a double-blinded trial, the patients and even the doctors don't know who is getting the drug and who is getting a placebo, just to see that the effect is real. A lot of the times our body is so good that even a mind can create a lot of solutions. So, and many of us thought that cancer would be the one that to focus in India. But unfortunately, the growth was very slow in cancer. Why? Because here most of the medicines were not available and it was very expensive. So what is the point in knowing that this is the mutation if you can't afford the medicine? Or the medicine, even now, many of the medicines are like, not available or cost lakhs or crores. But some, the patent period are over, so some of them we have the, the generic, the biosimilars that have come up and But still, a lot of the medicines are not available in India. So cancer was not taking off well. Then surprisingly, from the market, from the doctors, we started getting inquiries for sequencing for children. And we were so surprised. I didn't even know that such a need existed. Because unfortunately, in India, because of the earlier caste system that we mentioned, and not only just that, but due to many factors related to that, as founder small groups, we were interbreeding among ourselves, and so the inherited genetic disease component for Indians is much higher than the Caucasian or the Western population. So we have large number of specific diseases, which children are born with that. So, and many of the doctors, most of the doctors, so the families don't know why. The child can't walk, or the child has epilepsy, or is not talking, can't hear. Many of these problems, it's not like a single problem. So they would come. So they heard about the sequencing. So even the doctor may not know, but they will tell the doctor that I heard there is sequencing to find out which gene is wrong. Can you do the sequence? So the doctors would come and would send us, call us and say like, hey, we don't want cancer, but we would like to do the sequencing for a baby. And at that time, sequencing for the baby would be costing like about $1,000. And we would say like, are you really sure you want to spend that much money? Because the baby is already born. Now we have to find out, take all the genes, sequence them, and try to find out which gene is responsible. Very difficult. So our success rate, we'll tell them, is only about 30 to 40%. Many of the times we may not be able to figure out which gene is causing this. 30 to 40% chance you have. It is so costly. Then thirdly, what will you do? The baby is already born. So, but still business is business. So if people are asking us to do, we quickly developed that test and we started doing. And that's the inherited disease section that you see. That actually built up the company, Genome. So then cancer, of course, slowly picked up as more medicines became available in India. Cancer is there. Then because of the first one, the inherited disease thing, the reproductive segment started growing. Reproductive segment started growing because there are many mechanisms now to figure out whether the baby is carrying a bad gene. So NIPT was the biggest development in the reproductive world, where you could just take mother's blood, so you didn't need to poke the fetus. You can just take a mother's blood, the fetus cells are floating in the mother's blood, you can take that out, and then you look at the genome and see if the baby is carrying Down syndrome or many of the major diseases. It is not a cure-all, it can't pick up all, but in due course it may pick up more. But now at least some 20 to 30 very important diseases which can even create so much problems can be detected, right, by NIPT. And then there are many other ways, things of like reducing your risk. Carrier screening is the most important, which I try to push in every talk. People, both male and female, you should do carrier screening before you conceive the child. So if you do that, then you can know, hey, are you carrying some bad genes? Like I said, you are, everybody. But is your spouse also carrying the bad genes? Now, is the rare chance that are you both carrying the same bad gene? So that quickly, if you know that can quickly figure out, you can figure out many different ways to avoid the baby getting both the bad genes. So that can be the biggest impact that genomics can actually make in India. The technologies are there, cost is not that much, but awareness, the government, everybody need to move. China, by the way, does NIPT for every single baby born in the country. Many years back itself, 4 to 5 years back, I had visited China. I was trying to see how they were implementing this. Because here, we launched NIPT for the first time in India, and I could see the pickup was so slow. People are not understanding it. People are thinking that it is God's fate, that my baby, if it's born with a major disease, that is my destiny, we won't do it, and many other worries. And it has to be done in a short period of time. Because once you cross the 21 weeks or something, then you can't do anything about it. So the government rule of that. So, and you can get the fetus cells only after 10 weeks. So of pregnancy, I'm saying. So the 10 to 16, 17 weeks is the window that you have to take the mother's blood, and simple test only. Just 8 ml of the mother's blood is enough to do that, but still not picked up. When I went to China, I saw that, hey, government had just divided the whole country into 7 pieces, made 7 companies. Each company was given each region, no competition, and every pregnant woman, the government funded, was sequenced. Government paid the companies. So business came up, their genetic diseases. So maybe one more point. So last one was the infectious disease. Sequencing was not very much important there because the microbes are small and you can look at many other earlier technologies to figure out what is the infection and all that. So that was the smallest division, and sequencing had not made much an impact in infectious diseases. But that changed in 2020, right? When COVID struck, the only reason you all got, or we all got the vaccine, is because of gene sequencing, right? Within a few days of discovering the COVID virus, labs across the world were able to sequence the virus, right? Quickly point out what is wrong, what is the part causing it, how does it get into the body, where does it get in, what is the receptor, why do some people get it, why do some people don't get it, what are the mutations that increase the chances of you getting COVID, though those are not fully used because of many reasons, but those are all found out. But the most important impact of knowing was that we could quickly make a vaccine. So what would usually take 5 to 10 years to create a vaccine, we were able to do it in a few months actually. So within the first 7-8 months, clinical trials had started for the first vaccine. It was not just because of sequencing. There are many other technologies, mRNA, many other technologies that allowed us to build the vaccine, but the foundation came from genome sequencing. Without knowing the sequence of the virus, you can't do anything about it. So I just made a simple list of some of the most important inherited diseases in India. But to get a full list, you can go online. There are about 6,000 odd diseases. And this affects a lot of children. So this is one that we can practically prevent, just like the way we eradicated polio. We can eradicate these type of genetic diseases by a simple test, either before conception, I call the carrier screening. One brand name is Sequel, and then the NIPT, that's after the baby is conceived. Do a quick check after 10 weeks for the mother, and you can figure out if any of those diseases are there. I mean, the disease-causing genes are there. Now here, these genes or these disease-causing genes are not like a factor that increases your susceptibility. These are the bad cases. If you have a bad gene, you will get it. So not like the cancer cases and all that, where you have a bad gene, because cancer is typically not caused by one gene mutation. You have that bad gene, but maybe 1 or 2 bad mutations have to happen to have that concerted effect of creating the cancer. So it only increases your chance of getting cancer. And many other diseases are like that, cardio, autoimmune diseases and all that. Most of the genetic mutations only increases your chance. But the inherited ones, which are called the Mendelian diseases, if you have that bad gene, you will get it. So we then move to cancer. So inherited disease is the biggest problem in India. The second biggest, as in all other countries, is cancer. So some of you might know the Angelina story. When the first BRCA test, BRCA is a gene that has a very good chance to cause breast cancer. You inherit it. So from your mother, typically. So she was one who had, became the star posters because for popularizing the fact that all breast cancer patients should check whether you have a BRCA gene mutation, whether your cancer was caused due to BRCA, BRCA, the name of the gene. And then at that time, solutions were less, but she took the drastic effort, this thing of doing double mastectomy and even getting rid of her ovaries because she already had children by that time. But now there are much better ways of managing that. So very nice book if you want to know more about cancer is The Emperor of All Maladies, Siddhartha Mukherjee. One of the rare science books to actually get a Pulitzer Prize for literature because he's written so well. It's actually a masterpiece in literature that tells you everything you need to know about cancer. Then there's a third one is the next step that happened in cancer. That is where we developed technologies to use our immune system to fight the cancer. Because typically, how does cancer really happen? Cancer is happening because some cells are going out of control. Some of the genetic mutations that happened, some which you inherited, some which happened naturally, either through your cell division or through to some other effects like smoking or too much drinking and all these, caused other mutations which enabled that cell to get out of the surveillance of the immune system. By the way, our body is always having cancer cells, so don't think cancer is something very unique to the cancer patient. All of us have cancer cells in our body, but they are small numbers. Our immune system is pretty good. So they detect these cancer cells as the number increases, they kill them off. And this is not like a hypothesis. So now you take your blood and you check, you can actually extract the cancer cells and see the amount of cancer cells that are floating and what type of cancer cells are floating in your body. But like I said, the immune system is good, typically good. But occasionally these cancers are also evolving, the cells divide. Somehow there are many mechanisms, they get by chance one mechanism that can overcome the immune system or cheat the immune system. The immune system no longer sees that as a foreign cancer, sees it as part of your body, and the rest of the body gives it blood and nutrients and all that, and that continues to grow. So the final solution, the master solution for cancer is somehow to train your immune system and tell that like, hey boss, there is these bad guys here, and point the immune system to them, saying like, these are the bad guys. So if you're able to tell them that, then this is a complete cure, permanent cure for that cancer, right? Because cancer patients always know there is always a recurrence, the chance of cancer coming back. But if it is your immune system that has been trained to solve the cancer, then that particular cancer or that type of cancers due to that genetic mutation will not come again. So that is a big breakthrough of understanding immunotherapy. That's why that book is called Breakthrough, a big breakthrough, and that has led to a large number of drugs in the last 7-8 years. So ending up with my last slide. So I write some of it in a business book called Sam's 12 Commandments for the Indian entrepreneur. So if you get a chance, you can read it and give a few copies to your library too. You can take and read it. I do talk about, though it's not a genomics or science book, I do talk about the importance of science and also talk about some of the things that I mentioned here and how this will drive something called a bio wave, which I felt. The bio wave is the future. So as you guys all get into business and entrepreneurship or corporate life, don't forget biology. This century is going to be the century of biology. So the bio wave is going to be very important. Personally also, because if you want to really manage your health, you better pay some attention to your genome. And not only from the health point of view, but if you really want to make money or do well in life, the bio field, the life sciences field offers a lot of opportunities. Thank you.